In this recording, we're going to review the technique called completing the square for solving quadratic equations. So let's start with this warm-up. How could you solve this equation in just 2 steps? Well, you need to undo the square, and you need to undo the subtraction of 3. So if you think about it, undoing the square, you got to use an inverse operation. You got to square root, right? Square root both sides. But what is the square root of this quantity squared? And it's not just x minus 3. If you remember, when you look at the graph of the square root of x minus 3 squared, it's actually the absolute value, right? It's the absolute value of x minus 3. We can't have any negative numbers come out of this principal root here. So that means when I square root the square, we always get the absolute value. So we've got the absolute value of x minus 3 equals square root of 5. Well, of course, the absolute value means that there is a positive or negative number that makes this true. So that means we've got x minus 3 is equal to the positive or negative square root of 5. And that's pretty easy. You can see how to get x by itself. You're just going to add 3 to both sides. And that kind of looks like something that could come out of the quadratic formula, right? 3 plus or minus the square root of 5. So now let's apply that to some completing the square questions. The one we're going to do together is this one. And it says, solve by completing the square, express your irrational root. So it's already giving us a clue that the roots are going to be square roots in simplest radical form, and any decimals should be rounded to the nearest hundredth. So first off, I don't like this 2 here. And when we were using completing the square to get it in vertex form, we would factor out a 2. But here I can simply divide through by that 2. Okay, because we're solving, we divide all terms by that leading coefficient. Okay, so we'll rewrite what's left. X squared plus 6x minus 4 equals 0. And now, to complete the square, what I'm going to do is get this constant term over to the other side. Okay, so I'm going to go x squared plus 6x equals 4. And now I'm going to try to complete the square for this portion of the quadratic. So draw our box. Eventually you might not need the box, but let's do it for now. We've got our x squared, and we're going to split the 6x in half, right? We go 3x and 3x, because we want this to be a square. We want the same factor on the top and the side. That leaves us with a 9 here. I'm going to write it with a color, so you can see that the 9 is being added in here to complete the square. So I must add it to both sides. If you have access to colors, you might want to use the colors in your notes. At this point, what I have on the left is a quadratic that can be factored as a perfect square trinomial, x plus 3 squared, which kind of matches the area model we have here. It's a square with x plus 3 at its dimensions, and that's equal to 13. Well, what did we do before? Well, before, when we had 2 steps to solve this, we square rooted both sides, we got the absolute value, and then we just solved for x. So we can do that again. We're going to square root both sides. We're going to get the absolute value here. So we've got the absolute value of x plus 3. And when I square root the right side, we just get, well, square root of 13 we can't do much with, right? It's not a perfect square. It doesn't have any perfect squares that are its factors. And then so we got x plus 3 is equal to the positive or negative square root of 3. And then to solve, you're just going to subtract 3 from both sides, leaving us with negative 3 plus or minus the square root of 13. So we've done it. We have expressed this in simplest radical form, because there are no perfect squares that divide evenly into 13. And we just now need to express it as a decimal round to nearest hundredth. So let's go to the calculator. We're going to enter negative 3 plus or minus square root of 13. So we come over here, we do negative 3. Now there's no plus or minus key, right? So we're just going to do plus the square root of 13. It's going to give me the decimal. And then to get the conjugate of this, to use a fancy math word, I'm just going to change this plus to a minus. Bring your cursor up on top, hit enter. It repeats what you had, and just edit that to make it a subtraction of 13. Now you've got your 2 values. Okay. We'll just copy that in, pop it in our notes. All right, and now we can just express that rounded to the nearest hundredth place. So I'm going to do something like that. Let's go with x is approximately 0.61 or negative 6.61. Those are the decimal approximations. And it's important to be able to convert that into decimals, because if we're really solving something with a real life application, we don't want square root of 13. We want actual numbers that we can relate to. All right, so I'm going to have you write down some steps. These are steps for solving quadratics by completing the square. You're going to write these in your own pace, just kind of summarizing what we just did. And then I'm going to give you an example that you can work out on your own. Okay, so hopefully you paused and wrote down those steps. Now here's the final example that you're going to work out on your own. It says, same directions as before, just solve this by completing the square. I'd like you to pause, play the recording when you've gotten as far as you can, or looking to check your answer. Okay, so hopefully you did that. To complete this square, it's already got the 13 over to the right side. It's already got the constant to the right side. So when I think about the square, I'm thinking about splitting the b, right? Splitting the b. 2x, 2x. That's why in the previous step I said take b over 2 and square it. All right? That's where we get that 4. So I'm going to add in that 4 here to both sides in blue. When I factor this, it's just the dimensions of my square, x plus 2 squared. Square root it, we get the absolute value. Absolute value gives us plus or minus square root of 17. Subtract 2 from both sides, we get that answer. It says to express it as a decimal, round to the nearest hundredth, go to your calculator, and those are your figures. Thanks for watching.